This conference will now be recorded.
Okay, so basically today's class is going to have this agenda that we will be concluding that paint application, and then basically take up your questions. So mainly that will be the thing. So mostly I believe this should not take more than 30 minutes for us to conclude our paint application. So some pieces that are remaining in completing our exercises that we will talk about. Then this is basically Q&A. Any doubts that you have, anything that requires revision, any topics that require revision. So this is mainly how we will structure. So rest of the session will be on this. Okay, so let's come back to copy. Yeah, so I have a Java file here that I'll paste here. Yeah, so eventually we had been talking about this MiniPaint application being 0 MiniPaint and Java being 0 MiniPaint. So this is what we had been building, and we have learned the concepts that are required to build this. So all the basic concepts we have talked about except drawing. Drawing I introduced in the last class, where this drawing can happen automatically. So we need to write some code behind this. Right? So today main focus would be on this portion of drawing. And that is what the concluding part is. So if I ask you about drawing, then what surface are we drawing on? What is this UI control that we dragged last time on which the drawing is happening? What is the built-in Java swing component? If you remember from last class, we used NetBeans to draw this structure where we pulled various components. We pulled, yeah, so Likita says it is panel, absolutely. So this is JPanel that we had dragged. And we also learned that JPanel class has a function using which we can get a graphics object, and using graphics object is what we can do the drawing. So this provides a graphics object which provides mainly drawing functions, right? And that is what we quickly took a look at, but today we will dive deeper in that topic. So if I say JPanel, and in JPanel we want to see Java doc. So I'm opening just the documentation of JPanel so that we can today understand things better, that what is involved in overall drawing. So if I go here, get content, I cannot here. Maybe it is inheriting that from something. So there is a get function. Or let me quickly check in the code that function was that we were using. Yeah, so drawing panel canvas. I call that class as drawing canvas. So previously there was a function. Yeah, if I go here, graphics G, that is the function we are calling, and how we are getting graphics, that is what we need to see. Go up. Get, yeah, content pane is the function. So this is the function that we are going to search for. It is not shown here. Get content pane, graphics. JFrame has it. Okay, we will see what that is. Where is current shape? Yeah, we are introducing it here. We are passing draw function. Anyway, I'll come to that. Last time, anybody remembers how we got the graphics object back from panel? Which function we used for that? Okay. Or easy way to search for is when things do not work out, Google helps, right? So we'll go with JPanel graphics example. So what we can do, we can quickly do a search on get graphics. Okay, Sirisha is saying get graphics was the function we used. Let me search for get graphics. Okay, that is not there in this. So graphics, paint graphics, create graphics, get graphics. Yeah, ideally, if I remember, it was get graphics functions that we were using, and here it is not showing get graphics. So here it is. Sorry. Yeah. So this is the function we used last time. From panel, you asked for its graphics surface. So once you get this get graphics on panel, you will get a graphics object. Now that graphics class is the crux for us that we are going to use. So two classes that we are talking about. This class is there in java.awt. So let's come back here and say in panel, we had a function get graphics. This function of panel returns as a graphics object. So this is a getter function on JPanel. Now, once you got the graphics object, what you can do with that get graphics, there are functions available in this. So key things that are required to know about graphics class is it has functions like draw line. Just see this function and tell me what all does this function need. Draw line requires using the current color. It is saying okay, current color. We don't know what is current color. We will talk about that. Draw line is one of the function in graphics class. That is what we are learning today. Graphics class has a draw line function. It requires x1, y1, x2, y2. That means it requires 4 points, sorry, 2 points in drawing a line. Because one will be the starting point, one will be the ending point, and then there will be a line connecting that. So draw line is that function. And documentation of function has told us that it will draw a line using current color between point x1, y1 and x2, y2. Same way, there is a draw oval function. It requires 4 parameters. Again, they are integral parameters. And these 4 parameters are xy, width, and height. Now, the way oval is drawn is it asks you for the bounding rectangle. That means it asks for one point x1, y1, and it asks for its width and its height. If you do this, whatever oval can be formed inside this rectangle, that oval will be drawn. So this is a function for draw oval. Because we are supporting 3 shapes, we are looking at all the 3 functions, which are built-in functions of graphics class. Let's say draw rectangle. There is a function for draw rect. It is similar to draw oval. Most of the function, if you see, they are kind of similar. They take 4 parameters, 4 integral parameters. This will help us in designing our draw function in our shape. Right? So these 4 functions that we have written. Now, 3 functions we have written: line, oval, and rectangle. But we had one more feature. We said filled if somebody selects. If somebody selects filled oval, then we should have it filled with some color. So let's see if there are any functions with fill. I'm just searching here. So this says, okay, fill rectangle, fill oval. These functions are there. So let's take this fill and put it here, void. This is fill rectangle. And another function we will do is fill oval. So these 4 functions we have selected, we have seen from the documentation that if we are aware of these 4 functions of drawing, which is filled or non-filled, and 5th function is draw line, because in line it doesn't make any sense to draw filled line or non-filled line. Line is a line, right? So all these functions are one entry point for us to do the drawing, and all these functions require these 4 parameters. So somehow we have to calculate those 4 things from the user actions, and we have to call these functions. One more function on graphics that we have to see is this says it is going to fill with the current color. Now, what is the way we want to specify the current color? What if I want to get this rectangle in red color? So color wise, we need to have a function in this class. Let's see, do we have a function for set color? The answer to that is yes. So there is a set color function available that we can use. This will be setter function. So we have void set color, and that function is also in the graphics object. So this is the necessary information about panel that we have extracted. Panel will give us a graphics object using get graphics, and once we get that graphics object, then we can use that for doing drawing on this panel. Right. So this is one part that we should be aware about panel so that we can complete our drawing. Second part that you should be aware about drawing on the panel is panel class provides you a function which is paint function. Let me see paint. So there is a function called paint. This is internally drawn on panel. So this function is of panel class. This function, and there is a function called repaint. These two functions are what are going to be of our interest. So repaint, I'll pick that repaint without parameters. Yeah, so I'll pick this function and extract the necessary information here. Yeah, so this is all that we needed for doing our drawing. There's nothing else involved apart from this. So let me close the documentation now. No more information needed. So let's understand how these things will come together to do our drawing. First, learn about this paint method that we have on a panel. This method is automatically called. Whenever we do drawing, this paint method is automatically getting called by swing components. If we are doing any action on a panel, this paint function without us doing anything gets called. Repaint is a function that we can call explicitly. This is called automatically. This is what we can call. Now, why I'm describing that using repaint and all is because think about it, when we are doing drawing here, when we will drag this point, then what is happening? This is paint is being called again and again. When I'm drawing one surface, I'm drawing that, but previous surfaces should also be available here. They should be present. They should not get cleared. All that logic will require these 2 points. So I have emphasized this point again because this is something that is required. Whenever we want to draw shapes on JPanel, we will require calling repaint method so that we can draw the shapes as we are dragging the mouse, and we can avoid losing old shapes. Right. So this point I'll emphasize with the example when we discuss. But overall, if I just highlight this portion, whatever is written here, it may be hard for everyone to remember the syntax. That is not what is the focus of these classes. The focus of these classes is everything that is written here. Is it making sense that these functions are of graphics class, graphics object we will get from panel, and then whatever we do on that graphics object, this will be doing the drawing on panel. Now, if we are redrawing something every time, we will have to in backend, although front end, whatever it looks like is the thing is working smooth. But today we are not going to be consumer of this application. Today we are going to be developer of this application. And in order to be a developer, you should know how the drawing works here. And there are 2 functions, paint and repaint, whose concepts that we are going to consume. Yeah. So can I say this highlighted part, context wise, at least we understood. Can you respond in the chat window if this thing that is written here is making sense, that we are going to use this information in completing our application? Okay, so I got 3-4 responses only. Okay, perfect. Yeah, so if this much you got it, then we will do our classes design and we will clearly see how the application is actually built. Right, perfect. So in order to do the different drawings in our code or in our shape, okay, before that I would want to emphasize one question that was filled in the feedback form. See, the information that you have filled in the feedback form, the point is not about pointing fingers on you and saying why did you write. That point is, do we understand what you are trying to say, and are we going to take any action accordingly? So somebody has put a question, which is a valid question, that phase 2 was supposed to be data structure algorithms phase, then why are we doing online classes on Java? So maybe that person is not aware of this brochure that we have. So this brochure talks about what all is the plan of phase 2. So these 8 topics, 9 topics here, plus there is an addendum of 3 more topics. If you see, actually OOPS concepts are part of our phase 2. So this 5-hour plan is for object-oriented programming concepts. So that is why we did these online classes on this. Because knowing OOPS concepts also helps you, and in interviews there are a lot of questions asked on this. So our phase 2's focus remains data structure algorithms plus OOPS concepts, right? So this is actually the phase 2's idea, that you should have OOPS concepts and its application to real world problem solving. So that is the reason why we are doing these sessions. Okay. So next we were designing, we said we need to now come up with the object oriented way of designing our classes. So we need a class which will be in our project whose purpose will be to draw a line. We need a class whose purpose will be to draw an oval, and we need a class whose purpose will be to draw a rectangle. These are the 3 classes we will be designing, and this is where we will be applying object-oriented programming concept, rectangle. Now, all 3 classes belong to one category. Can you tell me what is that category to which all these classes belong? Because we are going to define an inheritance relationship, we are going to come up with some base class here, and we are going to have all of them derive from this. That is the part we are discussing. So they all of 3 are, yeah, I'm hearing responses from people that all of 3 are shapes. Yeah, you can call them shapes, you can call them, they are geometrical structures. Yeah. So what we want to do is we want to define abstraction which is called shape. The reason we are defining this abstraction is tomorrow if somebody says to us that your project should also support one more thing, we should also support drawing of some other object. What other object can be there? Rectangle, oval, and line is there. Tomorrow if somebody says support triangle also. Yeah. So if we want to add triangle later tomorrow, we should have a straightforward way of seeing, of visualizing how our code is going to change, what new code we are going to add, so that triangle also becomes one possible solution. And you would see that real paint application that is there, Microsoft Paint, it supports many more shapes than what we are doing. We are just doing this, we are doing line, we are doing circle. So object-oriented programming is known for writing code in such a way that in future, if you want to add new features to your software, it should be easily extensible and existing pieces should be reusable. That is what is the goal. So let's come back and say shape is a class we are coming up with. So this is our class design that we are doing. So we said shape is the class and rest all will be subclasses. So we'll mainly focus on shape. So what function should shape have? Any shape. Is there any common function that any shape will provide? Yes. What is the common function that a shape will provide? It should have a draw method, right? So draw method will be there. We will say return type of draw method should be void. Now, another question to ask is, what input parameters do we need so that we can draw any shape in our paint application? Can you tell me that answer? What input parameters are necessary for us to do that? Okay, so people are saying coordinates. How many coordinates? Can you specify how many coordinates do you need? For now, we have current 3 shapes: line, oval, and rectangle. So yeah, 4 parameters. So we will call it as for now 4 parameters: n1, n2, n3, and n4. Reason I'm calling n1, n2, n3, n4 is because we saw for built-in function line required 2 points, and oval required 1 point, and width and height. So we will take these 4 parameters for every shape. Now, when we are inheriting this class in line class, we will interpret these 4 points as x1, y1, x2, y2. When we are inheriting this class in rectangle, we will interpret them as the 3rd and 4th value for drawing the width and height. So n3 will be width, n4 will be height. That is what we will understand. So now, if you consider all this highlighted portion, you will say we are missing something in drawing. We cannot do drawing until unless we have one more parameter with us. We are missing one parameter. Can you tell me what parameter we will need to do the drawing apart from x1, y1, x, apart from these 4 points? Type of shape. So Padmashri, type of shape is actually not the question here, because type of shape is we are going to inherit this class in line. Line will extend shape. So function that we write here, this draw function that we will be writing here, int n1, n2, n3, n4. Actual drawing logic will be here. Here we will write line drawing logic, right? Same way, we will write logic for drawing oval in the oval class. There will be a separate class called oval. So drawing logic will be going here. My point is, in our application, if I want to do the drawing, somebody is saying we need mouse position. That is true. Mouse will give the start coordinate and end coordinate. But drawing, where are we drawing? Can you tell me what component are we using for drawing? Panel. So in this function, I need to write a logic which should do the drawing on that panel. And panel is not part of shape right now. So how will we pass panel here to do the drawing, or what do we need to draw on the panel? That is the discussion we had earlier. You cannot do the drawing directly. Here you can write system.out.println, but how will you connect that my drawing, whatever I'm writing here, that should go and draw on the panel? What do you need? What is the connection? What is the link we are missing right now? This part answers that question. Yeah, so Padmashri says panel object. So let's hear Padmashri that we should pass a panel also here. Okay, P. Now, once you get the panel, Padmashri, how will we draw? Now, let's say panel is also coming here. So once you got the panel, P, how will you draw the drawing? Tell me. Yeah, anyone? Let's do the thinking. And this is the last step of completing our project. Can we directly draw on panel? How do we draw on the panel? That is the discussion we had earlier. Use a function in the panel. Hari Prasanna, which function in panel do we use to do the drawing? Information is in front of you. You just have to connect the dots. So how do we draw on the panel? If you are mouse clicks, yeah, mouse click is the event. But I'm saying forget about event. On this panel, go and do the drawing. Okay, yeah. Now I'm hearing people are saying paint function, repaint function. Okay, when I call repaint, paint function will be called. Paint function will do the drawing. Yes, that is the trigger point. That is where we will start drawing from. But who will draw and how will the rectangle be drawn? Paint function doesn't know what drawing it has to do. We have to write our logic, and that logic will be in line class. But my point is, in order to draw here, yeah, so Sirisha is saying we have to call draw rect function. Of course, we have to call draw rect function. Draw line function here. Which class is draw line part of? Yes, Sirisha, which class has draw line function? No, JPanel doesn't have draw line function. All these functions are not from JPanel. They are functions of graphics class. How do we get object of graphics class? Get graphics, absolutely. Yep, so that was the missing piece. So see, you have to get graphics. G is equal to P dot get graphics. So panel gives you graphics object, and then once you have graphics object, you do G dot draw line. Now whatever line you draw, it will eventually show up on the panel. Right? So this panel, if we do not pass, we will not have graphics object. We will not be able to draw the line. Correct? Now, one more point to think about is every time, every function will get a panel object. From panel, you are anyways getting graphics object, and then you are doing drawing. Then I will say, why pass panel? Why not pass graphics itself? Let the caller extract the graphics object and pass it here. That will be much better, right? Do you agree with this? That, yeah, because graphics object is what makes sense to us. Panel, we do not want to do anything on panel. We are interested in getting the drawing surface so that these shapes can be drawn. Okay, so this function will be able to draw a line. This will be able to draw an oval, and same way we can draw a rectangle. Let's again revisit our design. If I ask you the question, how will red line be drawn? We want our line to be drawn in red color. Then this function, which color will it draw in? Which color will it draw in? What if user has selected blue color and I want to draw line in blue color? What should set color we should do? So ideally before drawing, what you are saying is before drawing you should say t dot set color. But where is the color here? I don't have a color. For setting the color, we should also get color as a parameter, right? Yes. So we need one more parameter, so which tells us, hey, which color you want to draw in. Color C. Color is a built-in class in Java AWT. So now you see this is how we are thinking of our scenarios, that we need color parameter also. Otherwise, our draw function will not have enough information. Now this is where a point comes, that if you want to draw a shape in default color, we can remove this. See, now I have put two functions, one draw function which is not taking color, one draw function which is taking color. This first function, if somebody calls, we will by default we will draw in black color. That is what our implementation will be. If somebody passes a color, we will draw in the given color. Now these two functions are called the two functions belonging to the same class, having different set of parameters. This is called function overloading or overriding. Overloading. Yes, this is overloading. And the purpose of overloading is always to give more options to the users. So there is one default behavior, one overloaded behavior. Right. So yeah, we have come up with these functions. Is there anything else we are missing? Look at this application. So far we have come up with two functions shape needs, one with color, one without color. Graphics is a mandatory parameter. 4 points are mandatory parameters. So this is what we have seen. Are we missing anything else? Yeah, solid or normal. Good point. So this function right now will not take care of solid or normal. So we should have one more parameter, that if you want to pass it Boolean, filled or not filled, right? And it is good to think of these functions in advance so that you can consider like adding all the parameters that are needed. And we can also define an overload behavior here. We can say this will be not filled and black color. This is the default behavior. And this is a simple function we are providing. But if you want it filled and with some color, you should call the second function. Make sense? Like you're clear like why our shape class has these two functions and what is the thought process that went behind writing these functions. Yeah. And all this that we have done, it is not that we have done with our bookish thinking. All that we have done is by looking at, hey, what are the requirements? What are we building? Because that should drive how we will design our classes, how we will design functions. Now, imagine if you have all these parameters coming to you. Can I ask you this question? Can I say you can use built-in graphics object? That means drawing the line, doing drawing is not your problem. Your problem is only figuring out these coordinates. Can I say that implementing these functions, draw here, and draw here, in these three classes, implementing these three functions is not a big deal now, because we know the built-in functions of graphics class, and we have made sure that graphics class and Boolean and color necessary parameters are available. Now all we have to do is we have to utilize these functions wisely. And these were not more than 6 functions, right? 2 to 4 to 6. So this has made your life simple to write this class hierarchy, making a shape class This shape class will not give the implementation of draw function. All these two functions will exist in shape class and they will not have any body. What is such class called? A class which has functions, just declaration of function, not definition of the function. Abstract class. So we are saying shape will be our abstract class, and every shape must inherit from the shape class so that it abides by the rules of this. And you will see the benefit of why bringing in base class, which is abstract class, is necessary, because it will simplify the code we will write on the UI side. It will make it uniform for UI to call any shape and draw. Right? Now, many people say rather than designing shape as an abstract class, in fact, you could have also done, you could have defined an interface also. Interface I shape. I'm just putting I in the beginning, so it helps us differentiate this is interface, this is class. And we could have added both these function declaration there also. And this is very frequently asked interview question, that if you can define functions declaration in abstract class also, interface also, then why Java gave you two concepts, separate interface and separate abstract class? What is the need for them? If interface were serving the purpose, why abstract classes were invented? Does somebody have answer? Abstract class is a class which has at least one abstract method. Same thing we are achieving with this. This has both abstract methods. Then why are two concepts needed? Okay, yeah. So Nilima is answering that question. The benefit of having abstract classes, in this abstract class, imagine if you want to define body of one function and want to leave body of another function. That is doable in abstract class. Here you can have some functions can be implemented here, but interfaces you cannot implement any function. No function to be implemented. Now I will change my question accordingly. Imagine if I say, if you have only abstract class concept but no interface in Java, if Java did not have interfaces, still abstract class would have helped you achieve what interface is providing. Put all the function in abstract class without body, then abstract class is equivalent to interface. Do we all agree with that? An abstract class with all functions as abstract functions which do not have body will be treated same as an interface. Yes or no? Can you use chat window? Yes. So if an abstract class does not have function body, then it is equivalent to interface. That is where the interview question comes. Then why interfaces are there? If abstract class can achieve both, then why do you need interfaces? Does anyone have answer for that? So again, your Java knowledge question, which you have done in your college, Java as a subject. So what is your answer to that? We cannot extend abstract class. Sirisha, we can extend abstract class. Here we are doing that. This is abstract class, we are extending. Inheritance is applicable to every class except final. There's a final keyword. If a class is final, you can inherit from it. But abstract classes can be extended. Okay, since that is an off-topic question, I'll simply tell you. Interfaces allow us to use multiple inheritance. Yep, that is the reason. Is possible from interfaces, but not abstract class. Yeah. Okay, so the repetition point was, imagine like you are saying line is a shape, so you can extend abstract class. So multiple inheritance, it allows one class. In Java, the rule is one class can inherit from only one class. So Java does not have multiple inheritance for class level. That is the point. But one class can implement more than one interface. So this is useful in scenarios. As I said, imagine. Yeah, somebody unmuted herself. Yeah, imagine student is a class Now human being is a base class. Human being is a base class. So student can inherit from human beings. And same way, you can have another class where you say this is Hyderabad based human beings. This is Hyderabad based human beings, right? Imagine these two classes are totally different classes, and you want student class to implement all the functions of this class as well as this class. Student should inherit from both of them. Java does not provide multiple inheritance, so it is not possible to inherit from both the classes. So what thing is used is people say whatever function human being class has, put them as interface. Now this is interface, make this also interface. Now student can implement both the interfaces. And that way we are able to push to student that student should be able to implement all the functions here, all the function here. So if interfaces were not there, we could not have achieved the multiple inheritance, which is available in Java using interfaces. Right. So this is like, obviously I'm not going deeper into that concept, but that is something that you can revise and look at back. But there are these 2-3 standard interview questions that get asked on interfaces and abstract class, which you should be clear about so that interviewer does not confuse you when he's asking these questions. So many times they say like interface is a entity in Java which can have all the methods unimplemented. Then they say in abstract class also you can have all the methods unimplemented. You will agree to that. Then they say, okay, if that was the case, then interfaces should not even be required. We can achieve same thing using abstract class. Why did Java folks add interfaces? And in an interview, when we hear that question, we feel like, yeah, what you are saying is right. And they say, can you think about what is the reason behind that? And that is where they take advantage. If we are not even able to think of anything, if we are not able to put our thought clearly, then kind of you can assume like what your feedback is going to be, right? So pay attention to the details of this topic. So this would help you in your interviews if somebody tries to put question on abstraction. Okay, so coming back, we said the draw functions we have designed properly. Now, in our example, right now we do not want multiple inheritance. So in our example, it doesn't matter whether we are taking shape as an interface or shape as an abstract class, or many people with conservative thinking, they simply say whenever you are designing at first, do both the things. Design an interface shape, put the functions there, design an abstract class which implements that interface, and then inherit from abstract class. So that is what people use, and that is the design I have used in our example, right? So I'll show you how our classes are designed. If I go back to I shape, just see what is I shape providing. Right now I have given only one method here, draw, which takes graphics. This is the default method. Now I shape, here we can add more methods also. So after iShape, we are implementing an abstract class which is implementing this iShape interface. This is our abstract class, and here the benefit clearly comes out. Since each shape will require 4 points, what we have done is we have defined at one level. So inheritance will help us inherit all these fields in inheritance classes. So I do not need to define these again in the derived classes. And these parameters I have left as default. Right? Ideally, we can make it protected so that only inheritance, the classes which are deriving, they can use. For now, I'll keep things simple. Let's put this. So shape has these 4 points. Shape has a color because each shape we want to put a color. Now up to you, you want to put it here or you want to give in drawing. So what I'm doing is I'm passing everything in the constructor so that draw method can be left as lightweight. Earlier we designed draw method to be heavyweight. So this was one possible way we thought. This is another possible way. So in my case, in your case, in this thing that we came up with together, we said if client is using this function, first that client will create a shape using default constructor and then it will pass the parameters. In this case, we will be calling the constructor with all the parameters and then we can call draw method with just one parameter. Right? So both implementations are same. There is no difference essentially. Only change that is going to happen is in the code which is calling the draw. So if I just ask you, is this line highlighted portion? Declaration of shape. Is that clear to everyone? Yeah, declaration of shape. This is an interface. Is that clear to everyone? Making sense? Perfect. Abstract class syntax is clear to everyone? Perfect. We are calling this class abstract because it has one method, draw, for which it is not defining the body. That is why this function is abstract, this class became abstract. Now let's take a look at our line class or rectangle class. Rectangle is inheriting from this. So in rectangle, we are getting 4 points x1, y1, x2, y2, but draw rectangle needs width and height. So I'm calculating width and height using absolute function. So this is clear? Yeah, we can do math.absolute. How will we get the width and height? So if you know one point here and you know x2, x1, y2 point, then width wise, can I say the difference between x1 and x2 will be width and difference between y1 and y2 will be height? Do we all agree with that? Yes, and that is what we are doing, width and height. And there is a TLX, TLY. Why we are doing TL? Because the built-in draw function, draw rectangle function that we have that requires top left X, top left Y. But when user draws on our paint application, he can draw things reverse way also. He can start from the bottom and draw like this. Right, let me rerun it. Yeah, built-in draw function of graphics class. In order to draw a rectangle, it requires 2 points, top left and width and height. But we allow user to draw from the bottom up like this. So in order to do this, we are passing two coordinates, x1, y1, x2, y2. And here we are doing all the magic of translating those input parameters to what draw function requires. So this is our input parameter of rectangle. Is filled or not filled, we are passing as a parameter. Color, we are passing as a parameter. And we are calling superclass function to initialize these fields. So super keyword is used to call the superclasses constructor. Now parameters are known. Now draw function is checking. First thing it is doing g.set color. Whatever color we got for drawing, that color we are setting. And then we are checking if it is filled, we are calling fill rectangle function. Otherwise we are calling draw rectangle function. So this makes sense that how rectangle class comes into picture and how it is using object-oriented programming concepts. Hey guys, is it clear to everyone? Can you respond? Yes, no? Maybe if anything requires re-explanation. Okay, perfect. So now you see that our shape class and shape class hierarchy is perfectly clear. The only thing we have to figure out is when do we create objects of the shape class and when do we call the function? That is where UI will come into picture. And there are few questions I'm going to ask you which will clarify that point. So last time we discussed drawing the UI is not a problem. NetBeans helped us do that. So once you have got that NetBeans UI, now tell me, if I imagine if I have selected line, if I want to draw here, what is it that is involved in programming? First of all, I will take my mouse cursor here, press the mouse button down, and I'll drag it. And at one point, I'll go and leave it. So how can we capture x1, y1 and x2, y2? These two things is what we need to draw a line. Just line I'm talking about. Yes, so Hari Prasanna says when mouse press happens. So when mouse press happens, Hari Prasanna, what should I do? What point will I get? Start coordinates, absolutely. So wherever I'm pressing mouse, they are x1, y1. Now if I'm dragging, wherever I'm taking, I'll get, wherever I leave mouse, there I'll get x2, y2. Correct? So I want to handle event of mouse press at the beginning and mouse release at the end. Do we agree with that? Mouse press and mouse release events is what we are interested in. Perfect. Who is the event source for that? Where should we add our event handler? What is the UI component, which is the events for mouse press and mouse release? We talked about every event will have a source. So who is the event source? Drawing panel, absolutely. So let's take a look at our drawing panel. Mouse pressed, you see this add mouse listener, and which is this class of, we have taken a drawing panel extending JPanel. So we have created our panel class, and this class ideally, if you see, this is an inner class of our main window. This is main window class, and we have an inner class where we are defining panel. I'll also clarify why we are taking inner class, but for now, just see that drawing panel or drawing canvas is an inner class, which is nothing but a panel. And in that inner class, in constructor, first I'm setting background color white, then I'm saying add mouse motion listener and add mouse listener. Mouse listener is what has the mouse pressed event and mouse released event. And here in place of this, you can write the interface or class name. So this is the adapter class. I think we have talked about this concept earlier, right? So only thing that we need to worry about is we are implementing these two functions. Just look at this function and tell me what we are doing when mouse gets pressed. What is this function doing when mouse press happens? We are getting coordinates of start point. And when mouse releases, what we are doing? We are getting x2, y2. And after x2, y2, here we are doing one more thing, because when mouse is released, we want to draw that shape also. So we go to switch case, which shape user has selected, we are checking. Out of these three, which one is selected? Because we have to create object accordingly. Imagine if line is selected, we go to line, and what is this line trying to do? What is this line doing? This line will do the object instantiation. We are creating object of line class, correct? Now we got that object, and see, we are able to create line here, we are able to create oval here, rectangle here. Now, since we used inheritance and abstraction there, all these classes are kind of shape. S is an object of shape, which is the base class, and here we can simply call the function. Okay, we have to eventually, can I say, for now, I'll come to this point. Can I say at the end, what I want to do is I want to simply say s dot draw. Do you agree with this? S dot draw, and I have to pass this dot get graphics. This is what I just need to do the drawing. Do we agree? Perfect. Because drawing is something that that particular shape will take care of. Now, can you tell me, are we using runtime polymorphism here? Is it using runtime polymorphism or not? Tell me. Is it using runtime polymorphism? Yes. Because runtime polymorphism said this draw function, how it will behave, it is dependent on which object you have created at runtime. If you have created line class object, this function's behavior will be different. If you have created oval class object, then this will have a different behavior. Otherwise, it will have rectangular behavior, right? So this is what is runtime polymorphism, and this is driven by user actions. Our program has become dynamic based on what user does. We are calling just one function, and that function knows how to behave differently based on what object you instantiated. Okay, but we did not call draw here. I'll talk about why we did not call draw here. First of all, we have put this shape in completed shapes. Completed shapes is nothing but it is a list, array list of shapes that we are tracking at window level. So whatever shapes we have drawn so far, all of them will get added to a list, array list, so that our canvas knows I have to draw 4 or 5 shapes. Second thing, we are adding this shape because user has just completed drawing it. We have added that to the canvas. Second, we are calling repaint function. As I said, we will call repaint function, which will call, if we call repaint function, which function will it call for panel? That is what we discussed here. We call repaint, it will call paint function automatically. And paint function is where we are overriding the behavior. Let me go back. Paint function of our panel is where we are doing some logic. Just read this function and see, help me understand what we are doing over here. This paint function, whenever we call repaint function, repaint clears up the panel. Whatever drawings were there, they will be erased. Then we are drawing previous shapes. Then we are drawing current shape. Is this function making sense? It's like with every mouse drag event, what is happening is we are going to draw again. And every paint application does that. That rendering happens at runtime. Is this function clear to everyone? So what we are doing is, in built-in panel, we want to have our own logic. Whenever we call repaint, we want to define some behavior. We want to put our own implementation. That is why we are writing this function. Now, can you tell me what concept of oops concepts we have used in writing this function? There is a keyword here that is pointing something. Yeah. Can you tell what is this highlighted portion representing? Okay, Nilima has asked a very good question. Yes, Nilima, absolutely good point. Nilima is asking her a question that I'll put here, and that is why we are doing this paint repaint thing. It will clarify that reason. So I'm putting her question. She's asking, sir, but shape will be visible only when we release. Does everyone agree with her that only when we release the mouse pointer, then only shape will be visible? But right now, if I see here, my shape is visible as I'm drawing. Ideally, it should be visible only when I release it. Perfect. So we have some logic which is handling this. So, and that logic I'll show you. Let me get rid of this. Let me get rid of this part also. Yeah, now you will see what you are saying. Yeah, I drag mouse, leave it, now line comes. I drag mouse, leave it, now line comes. So same thing for others also. I drag my mouse, now oval comes. So can you tell me what additional thing we have done so that when the person is drawing, shape should be visible that time also? That's an additional thing that we want to do. And that answer is basically in the code that I have commented out. What is this event? This says mouse dragged. That means when user is dragging the mouse, that time also we want the shape to be visible. So this mouse dragged event, what I'm doing is every time mouse drag event is called, we are capturing x2, y2, we are creating the same shape again, and we are putting that, this time we are putting that in current shape. And current shape is a variable that we are using based on what we are drawing. So current shape gets updated, we call repaint. Repaint will erase everything, and then it will draw all the previous shapes and current shape. The previous thing gets, so imagine when I'm dragging my mouse, if I have extended my line like this, all these lines would have been visible. So that is why current shape we are not putting in completed shapes, and current shape we are drawing only one. So clear the panel, draw all old shapes, and current shape wherever it has reached, draw that. Right. So to get that good effect that when user is drawing, show the image immediately, that time also we are using this mouse drag event. Does that make sense to you, Nilima? Yeah. Does everyone get this point? Yeah. So we wanted to have a good behavior that we want to show the shape immediately also. And all this that you are seeing right now, it is nothing but a heavy use of event handling. And you see a good application comes to life. It is, if I ask you, like the project is using event handling, Java Swing, and some geometry concepts, or sorry, graphics. And in this also, we are more using JPanel. The important thing to know is paint and repaint. So these four concepts combined together is what helped us build this application. Okay, so this was the conclusion. Now you can say like everything has come together in one place and you are able to see how this working. So I'm going to share this code with you, but not the fully functional code. What I'm going to do is I'm going to remove the implementations that are there and they will be replaced by to-dos. So you will be filling the code there so that it helps you do this exercise on your own to think about where I have to attach which event handler. So mostly like when you get this code, it will be written like to do draw existing shapes. And here it will be a to do draw. It will be draw completed shapes, drawing current shape. Right, so you will get the UI code because UI wise I do not want you to waste time, but other things which are required for you to experience yourself, those things will be given as exercise. So this code as an exercise will be available to you. Yeah, makes sense. Perfect. So this is what the series was about. Now if we have to summarize the entire thing that we have discussed, ideally any project that we start in object-oriented programming, it starts at abstraction. Once we think of what will be my classes, what will be my function, think of the UML diagram, that is abstraction. You come up with your classes, come up with classes, their fields. Fields in the classes means data members and functions. And then you come up with the relationships. And then later on, after that, you start coding. Relationship covers is a, which is inheritance, has a, which is containment, and uses, where we start using things. Now, one question just to kind of re-emphasize, if I ask you, this oval shape class and graphics class, what is the relationship between these two classes? This class and graphics class. What kind of relationship do they have in this design that you are seeing? Yeah, can you respond in the chat window? What is the relationship between these two classes? Three choices you have: is a, has a, uses. Yeah, can you put your answers in the chat window? What relationships do these two classes have? Perfect. So all answers that we got is uses, yes. Because this class is not available as a data member. This class is not the super class, so this is uses. What is the relationship between oval shape and shape? What is this relationship? That is we can say oval shape is a shape. So we have experienced inheritance, we have experienced uses relationship. And now if I ask you, from this entire application, give me an example of has a relationship. Any two classes in our entire example where we have used has a relationship. Yeah. Think of entire paint application that we talked about in your mind. Multiple classes we are using, built-in classes also. Any two classes in our overall thing where you can say there is a has a relationship. We have used all three relationships. Okay, rectangle has lines. But Prasanna, in our example, we did not design our rectangle class like that. I want that example coming from our thing. If you talk about rectangle shape, I'll take you to that. In this rectangle shape, do we have any relationship of this rectangle with line? In our design, it is not there. In general geometry, what you are saying is right. Perfect. Vaishnavi has given a good example. So Vaishnavi says JPanel has graphics. Yes. Padmashri says graphics has set color. Padmashri, set color is a function, not a class. When we say we are defining relationship among class, then we say that there should be two classes, not class and function. Classes certainly have functions. Okay, Pooja is giving another good example. Our window, our paint window has a panel, drawing panel. Do we agree with that? That this entire window, which is a J frame, has a J panel, which is this. Do we agree that is a has a relationship? Can you respond in the chat window if we agree with what Pooja is saying? Pooja says window and J panel has a relationship. Yes, that is correct, Pooja. And that will be reflected in the code also. If you go back in the code, this is being zero main window, which is extending J frame, and that window, I think I have put them somewhere together. I'm searching for where are the data members I have defined for this class. So let's go gradually. So this class, there will be some members of this class defined in one place. Yeah, all these members are there in our paint class. So it has a J menu bar, it has a toolbar, it has a drawing canvas, it has a mouse position label, it has a color chooser. Can we say all these classes kind of reflect the has a relationship between our paint and these components? Can I also say this window has a menu bar, this window has a toolbar, this window has a status bar, right? So all these are has a relationship. And why they are has a? Because we are having that class object as a data member of our window class. Perfect. So to end it, I was saying something, yeah. So we start with abstraction, we come up with the classes and define relationships. Then we use, when we start implementing our classes, we use inheritance and polymorphism. And typically people say we can end it with encapsulation. This is hide the unnecessary. Now why I have written them in this way is because we will be easily able to correlate it to a real example, not of software, but non-software example. Imagine when construction of a building starts. Imagine any developer is constructing a building. If you have a plot and you want to make a house on that, what is the first step we get? Land is there. Let's say raw material is also purchased, bought. Material wise, we are not talking about. What is the first thing that is required to have a building work started? Or typically when we buy a flat, when we buy any apartment, we look at something. Yeah, we need a plan. Pooja says we need a plan, right? There will be some sort of drawing which will tell, hey, if this is the flat, here it will be the entrance. This is the entrance. Here you will have a master bedroom. Here you will have kitchen. This is the plan. Somehow we take a look at, then we decide. This is blueprint. Yeah, especially we are using the right term. We call it blueprint. Can I say this blueprint is not the actual implementation? This is not actual house, but it is giving us an idea what the house will look like. For anybody, it gives a clear indication that how much space is used. They give dimensions also. It will be 3x7 or 13x17 bedroom. What will you call this out of 4 OOPS concepts? What is this plan representing? This is not the implementation. What is this out of 4? Nilima says class. No, this is not a class right now. Is this bedroom built? Class is something, yeah, abstract class you can say. It does not have any implementation. This is not the real room, but this is interface or abstract class. So we typically say this is abstraction of that house. So building construction starts with an abstraction with a plan. Now that abstraction, when you start implementing, you find a person who has experience of constructing the building. You find some contractor who can start building it. So reason we find someone who has already constructed buildings is we want to use his knowledge, use his experience. That is where we are inheriting his knowledge, we are inheriting his experience so that we can get it done. Right? In our MiniPaint application, we found JFrame is a built-in class which will make it easy for us to design a window. So we quickly inherited from that and we made our window ready. Right? So inheritance is there, it is coming. Now imagine a person, a contractor who we found, he has constructed only buildings up to 5 floors so far. He has never constructed building taller than that. But we are constructing building up to 7th floor. So we are using inheritance, using his experience, but with little modification. That is where we use, if you inherit and modify, what is that concept? You are inheriting from a class, but you want to modify one of the function of that class. You want to change the behavior of that function. That is overriding, absolutely. So you are using overriding, right? So most of you would have seen the half constructed buildings, building under construction. To complete building, I just want to open one of the diagrams. Have you ever gone to a building where you can see wall has the pipes visible? The pipes are visible, the wires are visible, they are just hanging outside. Plastering is not done, covering is not done. Have you seen those houses where pipes you can see, wires you can see, right? So when wires and pipes are outside, I'm not able to find any good example. Any home, if you can see the plastering is not done, the painting is not done, but pipes are visible, the wires are visible, and the work is still going on. I'm sure all of you would have seen that thing. Before the house is handed over to the customer, what is done for those pipes and those wires that are visible? What does builder do for that? Can you tell me what does builder do before handover? Yeah, they cover them, right? So can I say they hide the unnecessary? Whichever thing, yeah, they do plastering, and plastering's purpose is to hide whichever is not required day to day. Encapsulation is about hiding those things, right? So this journey we talked about constructing a building, but same journey we say when you are building software. Ideally, encapsulation, we can hide the things later. And people who plan things better, they start with encapsulation also early. They say, let's start with every field as private in the beginning. If something required to be made public or protected, we will see that later. Right? But this will help you remember the story, or this journey of construction or building will help you remember these concepts with ease. Same journey we can apply to software development also. Right? So yeah, with that we are done with those concepts. So assignment for you will be complete MiniPaint. We will send you the assignment UI code complete. You need to complete, you need to fill in to-dos and shape, line. These classes I'll totally remove. These classes you will be implementing from scratch, because that is where you will apply the OOPS concepts and overall. These classes you will be building. Now you build with class, interface, abstract class, all that is something that you will do. So that is the end of our OOPS concepts. Now we are open for any questions that you may have that you want to ask. Yeah. Any questions from anyone? Any topic that you feel requires revision?
This conference will now be recorded.
So we started with what class and all. Then we talked about basic case study where we started identifying classes which are focused on nouns in the problem statement. Okay, Nilima has a doubt from first day. Sure, Nilima, tell me what is your doubt? If you have mic, Nilima, and you can speak, that will be better. Just unmute yourself and speak if you do not have any disturbance. The difference between has a and one-to-one relationship. Okay, good point. Okay, so that is a doubt she's asking. So imagine if two classes has a relationship. Has a relationship again is of two types. You can have one-to-one and one-to-many. Good question. See, if class A, this is, let me call it an object of class, data member class X. This way we say data member class and enclosing class has a relationship, right? But how many objects enclosing class have of data member class? Can you tell me how many objects this class will contain at any time? How many objects? Enclosing class will have this. So if I ask you in a different way, student has a name. So there is a student class we are talking about. There is a string class we are talking about. Do you agree has a relationship between these two classes? Everyone, can you type in the chat window? Do you agree? Has a relationship. Student has a name which is of type string. So student and string class has a relationship. Perfect. Now, if I say student, how many pens do you have roughly on an average? Or how many notebooks you have roughly on an average? A rough idea, how many pens will you have that belong to you right now? Can I say student have a pen? Or I will say student will have a list of pens. Now you see two relationships. Student will have one name, but student can have more than one pens. So this should clarify there is a one-to-many relationship. One student can have many objects or kind of list of objects of another class. So does this answer your question? Yeah. And good that you pointed that out. In our case also, our main window has one JPanel, but our drawing panel has multiple shapes, right? So the shapes we are drawing here, there are multiple lines on the panel. So completed shapes, if you look at what this is a list. So you can say there is a one-to-many relationship between shape and drawing canvas, or between shape and main window drawing panel. So, yeah, so that is okay. So we did, apart from that, we did in first class, we talked about UML diagram, their notations. Then I introduced the MiniPaint problems in that class. And I said total we will spend 5 hours on this, and now you would be able to correlate to it. Okay, sir, also is one-to-one. So Nilima, is a relationship is one-to-one when it is inheritance, right? But when it is implements, when you want to implement, one class can implement multiple interfaces, right? So there you will say is a relationship can be one-to-many. One student is a, or let's say as a student, there is a one-to-many relationship. Let's say I daughter is an interface where daughter has certain responsibilities for parents. All the functions are defined here. Then you say I student is a interface which has student related functions. Then you can say I placement candidate. Now can you tell me, all of you are actually implementing all three interfaces? Do you agree with that? At home you are a daughter, in college you are a student, for placement department you are a placement candidate. So you are, so I will say we is a daughter, is a student, and is a placement candidate, right? So there is a in this scenario, you can say is a relationship can be one to many. A person can be daughter, student, and this. Yeah, so that is where is a relationship can also be one to many. Uses relationship can also be one to many. Multiple functions are using one class, right? But typically we talk about one to one, one to many only in case of has a. In is a, it is not talked about much, right? But still, yeah, valid question. I hope that got answered. Okay, so then we started with some example, give some small exercise for you to do. Has a relationship. Okay, this is what we talked about today. So first class, Hari Prasanna has a question. Sir, you told that we can achieve multiple polymorphism using interface. I just wanted to clarify a question. We cannot extend more than one class in a class, isn't it? So I'll take her question here. So multiple, I did not say multiple polymorphism, that is multiple inheritance. So it is language specific. Java does not support multiple inheritance of classes. You cannot inherit from more than one class, and that is Java's decision. C++ supports multiple inheritance, but Java does support one class implementing multiple interfaces. Right? This is again a Java specific thing. Is that making sense, Hari Prasanna? Any follow-up questions on this? And this will be justified with the previous example. You can have a class daughter, which is a student, which is a placement candidate. And it's possible to have one class which is having is a relationship with three different entities. But all three entities then have to be interfaces, not abstraction. Sorry, not class. If they three are classes, one class cannot inherit from all of them. Okay. So class 2, we talked about OOPS concepts. We spent time on event handling concepts. That is where we discussed the concepts of event handling, source handler, and something that connects both of them. And we talked about observer pattern. And this class was dedicated to total event handling. Here we also understood the concept of anonymous class, inner class, event handling, inner class, anonymous class. So this was the focus of class 2 that we did. And we talked about 5 types of handler. Any questions from anyone on this class? Okay, I guess no. So third class we did, which was our last class. There we talked about getters, setters, and we went in detail of polymorphism. And there we did a little bit more of discussion on what is overloading, what is overriding, and we try to understand that in detail. Then we started about MiniPaint application. We had some discussion on drawing functions, some painting, some examples of that. Yeah, so here also we talked about basic things. And overall, yeah, this was the focus of last class. And last class would have been in the sense like that time when we talked about drawing graphics object, it was a little fast because it was just introducing you to the concept. Our emphasis on last class was polymorphism so that we understand overloading, overriding. In today's class, we have concluded all things together and we have tried to make things come together. And main focus was in order to complete the paint application, the missing piece was going in detail of JPanel and graphics and paint function. That is what we have done today. And then we also talked about the class design for shape and other shapes. Right? Okay. Any more questions from anyone? Okay. If no, then I guess we are done for today. And rest of the things I'll send you in the WhatsApp group. Even despite after today's class also, if anything confuses you, if you feel like there is any question to clarify, feel free to use our WhatsApp group. Send your question in there. I'll make sure like every question you people send that gets answered. Right. Okay. Thank you so much for sparing your time. Okay. Vaishnavi is saying one more thing. Can you discuss practical example of access specifier? Sure, Vaishnavi, we'll take that question. Yeah, so practical example of access specifier is this. Imagine if you want to hide something, you will make it. If you want to hide something, Vaishnavi, you will make it what? 4 keywords are there, 3 keywords in fact, private, right? So you want to something, we will make it private. But making something private also means that even derived class will not be able to access it. Right? But most of the time we want derived classes to have access to something so that we can do things easily. For that we use protected keyword, right? Now, and public is something that I don't think we need to talk about. Typically, we do not make fields public. We will still talk about private because you have asked for real world example of that. So real world example wise, when you are calling some function on which you do not want to give much control to the outside world, then you will keep it private. An example for that be, imagine you are writing a class, and in that class you are giving a function which is internal to you. For example, let me think of the very basic case. Student has a field, date of birth, right? And this is a Facebook scenario we are taking rather than student, let's say member of the site. On site, Facebook shows to outside world that what is age of a person. When your birthday comes, they want to show a message that this person has turned 21 years today, 22 years today, but they do not want to reveal your date of birth. Scenario is clear that show age, but don't show date of birth to anyone. If this is what you want to achieve, then what you will do? You will put date of birth as a member class, right? And then you will provide a function public void int, sorry, public date, public int age. So you will give this function. Somebody calls this function and say get age, and they will always be shown the age. And in fact, age will be real time. If you ask somebody's age today, it will say 15. If you ask next year, it will say 16. And here you can implement your own difference logic to calculate age in years. So if age is the scenario on UI that you want to show, then you will hide this and you will expose this. This is one simple example that I can think of. Make sense, Vaishnavi? Sorry, Vaishnavi asked that, right? Yeah. And any other application where you say like the internal details are not to be revealed, they all will be private, right? How Paint is demonstrating or how Paint is actually drawing behind the scenes. If you want to keep that private, ideally this public private makes sense only from code that is using your class. That is your client and code that you are writing. Two different pieces are there. Most of the time at college level, we only write our code, we only use our code. That is where these private, public, default, they do not make much sense. But in real world, when you write APIs, when you write application programming interfaces, which other people can use, that is where this is used quite heavily. It's used there when you design library for others, right? What else we can see? Yeah, one more example I can quickly give you from our example also. So if you wanted to hide our own logic, like our drawing is taking how many parameters, we could have simplified. We could have given a draw function here, void draw, and this is default function. Internally, whatever it does, it can do by default. So you can expose this function to outside world and connect this function internally to draw graphics, and that is what panel does. In panel, if you see, we call this function. Do you remember we were calling it paint function? This is a public function which is available to us. When we call that function internally, this function is calling this paint function internally. We do not call this function directly, right? Same way, if you would have done multi-threading in Java, you know, in thread you call run function. You create a thread, t is equal to new thread, and you simply say sorry, you call start function internally, it calls the run function. So they have not exposed run function directly to you. That is where they have more work internally, which they do not want to expose outside. Right? Any more questions from anyone? Okay, then we are done. Let's stop here. And next class is plan and all we will discuss in the group. So thank you, everyone.